Hi students, welcome back to my channel. This video we are going to start the third chapter, which is the pair of linear equations in two variables. If you are new to my channel, please don't forget to subscribe. Let's start. So pair of linear equations in two variables. So we are learning that linear equations in two variables. We have seen so many equations like we know what is a variable. Variables are any alphabets which is shown like x. It can be represented as x, can be y, it can be a, like it can be b. Yeah. So these are the variables, and we know what is linear. Linear equation is an equation with the highest power 1. Let's see a few examples like x plus 4 equal to 0. So this is a linear equation. We have seen x squared plus 2x plus 3 equal to 0. So this is a quadratic equation but with one variable. It has only one variable. Then similarly we have x cube plus 4x squared plus 5 equal to 0. So this is cubic. So because the highest degree is 3, it is called cubic polynomial. Since it is an equation, we can say cubic equation, and this is quadratic because the degree is 2 and here it is linear. All these have only one variable. So here all have only one variable. So let's see another type of equations, which is like one is x plus y equal to 5. This has two different variables, which is x and y. These are called equations in two variables. We call it as linear equation, and since the highest power of x and y is 1. The power of two variables is 1, hence it is a linear equation. For another example, 4x plus 3y equal to 15, x plus y equal to 7, another one x minus 2y equal to 3. So these all are linear equations in two variables. So we have learned equations with different type, like more than one power, like linear equations, quadratic equations are with power 2, highest power of the variable is 2, and cubic equations are power of the highest power of the variable is 3. So the linear equations in two variables are, there will be two different variables, x or y, a and b, any of the variables, but the highest power will be always 1, hence it is all are linear because the highest power of the variable is 1. Now let's see how this can be represented in a graph. We all know the linear equations forms a straight line. When we represent a linear equation in a graph, it forms a straight line. We have learned that in previous chapters. So there are possible three types of pair, like if we plot two different pair of linear equations on a graph. If you are plotting two pair of linear equations, one linear equation will form a straight line and the another equation will form another straight line. So for example, we have an equation like 3x plus 2y plus 4, which is equation number 1 equal to 0, and another one x minus 5y plus 2 equal to 3. So this is another equation. If we plot these two are linear equations. If you are plotting these two linear equations on a graph, there are three possibilities of how that graph will represent. So first one is the two lines intersect with each other. As this picture, the one line is the linear representation of one linear equation and other one is the second linear equation. So it will intersect at each other. So if we draw a graph, x-axis and y-axis, one equation will be like this, the other equation is, and it intersects at one point. So the first possible way is intersecting at one point. And the second one is they will be parallel to each other. So it forms two different lines, but it will never intersect. They are parallel to each other. And the third possible way is they coincide. It will be the one equation will be like this and the other one will be also on the same line. So they coincide. So there are three possibilities of when we plot two pair of linear equations on a graph. So one is the two lines intersect at exactly one point, and the second possibility is they will be parallel to each other. They will never intersect. They are parallel to each other. And the third one is they coincide each other. So these are the three possibilities of graph of a two pair of linear equations. Now let's see the general representation of these linear equations. So we know a linear equation we can express that as a1x plus b1y plus c1 equal to 0. A linear equation can be generally represented as a1x plus b1y plus c1 equal to 0. Here a1 is the coefficient of x, b1 is the coefficient of y, and c1 is the constant. So this is the coefficient of x, this also coefficient of y, and this is the constant. And the second equation is a2x, which is the coefficient of x, b2y, b is the coefficient of y, plus c2, which is the constant. So when this is the general representation of linear equations. So when we let's see these two linear, but one is 3x plus y minus 5 equal to 0, and another one is x minus 2y plus 3 equal to 0. So let's identify which are the a1, a2, b1, b2 and c1 and c2 from these two pair of equations. For a1 is the coefficient of x from the first equation, which is 3. a2 is the coefficient of x from the second equation. So here it is x, so the coefficient is 1. So b1 is the coefficient of y from the first equation, which is equal to 1, and b2 is the coefficient of y from the second equation, which is equal to minus 2. We have minus here. And c1 is the constant of from the first equation, which is minus 5, and c2 is the constant from the second equation, which is 3. So we have identified a1 is the coefficient of x from the first equation, and a2 is the coefficient of x from the second equation. b1 is the coefficient of y from the first equation, and b2 is the coefficient of y from the second equation. c1 is the constant of the first equation, and c2 is the constant of the second equations. So now if we get to two pair of linear equations, we can identify this from the linear equations. So there exist three different conditions of this linear equations. The first one is a1 by a2 is not equal to b1 by b2. So like if we look into the previous example, a1 by a2 is not equal to b1 by b2. The second one is a1 by a2 will be equal to b1 to b2 but not equal to c1 by c2. So if we take the previous example, we know a1 by a2 is 3 divided by 1. So a1 by a2 is 3 divided by 1, and second one is b1 by b2. b1 by b2, here it is 1 divided by minus 2. So we can write it as 1 divided by minus 2. It is not equal to. So this the examples which we have seen previously will fall under the first situation. 3 like a1 by a2 is not equal to b1 by b2. The second condition, and in this case how the consistency of this linear equation is if consistent. So we can say a1 by a2 is not equal to b1 by b2, then we can say it is consistent. So and hence it has unique solution. So this type of graph will have the graphical representation of this linear equations will be, the possible way will be, it will intersect at one point. It will intersect at one point and it will have only one solution. It will have only one solution. Another one, a1 by a2 is equal to b1 by b2 and not equal to c1 by c2. So there can be chances like a1 by a2 will be equal to the b1, the coefficient of y from two equations. So there will be the coefficient of x from the first equation will be equal to the coefficient of y from the divided by coefficient of y from the second equation, but it will not be equal to c1 by c2. In this case, it will have parallel lines. If this is the case, the graph will look like parallel lines and it will have no solutions and it is inconsistent. It will have no solution. In this case, it will have no solutions and it is inconsistent. The third one is A1 by A2 is equal to B1 by B2 and will be also equal to C1 by C2. In this case, it will be coincident. So this is how it will be. The graph will be looking like one line will be here and the other one will be on top of that. So it coincides and there will be it has infinite solutions and it is consistent. We will consider it as consistent. It has infinite solution and it is consistent. So let's look that into in a table. So relationship between the coefficients of two equations. If A1 by A2 is not equal to B1 by B2, we know what is A1 and A2 and what is B1 and B2. A1 and A2 is the coefficient of x from two different equations and B1 and B2 are the coefficient of the second variable from two different equations. If they are not equal, then the graph will look like it will be intersecting lines. We will learn that there are three possible ways of when we plot two different pair of linear equations on a graph. There are three possible ways. So first one is when A1 is divided by A2 not equal to B1 by B2, the graph will be a intersecting line. So which will be like, the graph will look like intersecting lines. It will exactly intersect at one point and the number of solution is the point which intersect is the solution for this two equations. So it has unique one solution. And consistency is it is consistent. The second possible way is it forms a parallel line to each other. So which is A1 by A2 is equal to B1 by B2 and not equal to C1 by C2. And there will be no solution for this equation. So if we solve these two linear equations, we are not able to find the solutions. And the consistency is inconsistent. It stays inconsistent. The third relationship is A1 by E2 is equal to B1 by B2 is equal to C1 by C2. So it forms a coincident line. So it will forms like this way and it has infinite solutions. So it can have many solutions and it is consistent as well. So these are the three relationship between the coefficients of two equations and how the graph looks like and that is the number of solutions and what is the type of consistency. Let's look into this once again. A1 by x plus b1 y plus c1 equal to 0. We know a1 and a2 are the coefficient of x from two different equations and b1 and b2 is the coefficient of the second value, which is y. From the b1 is from the first equation and b2 is from the second equation, and c1 is the constant of the first equation and c2 is the constant of the second equation. So the relationship between the coefficients of two equations is directly related to the graphical representation of these linear equations. So if the relationship between the coefficient of two equations, if a1 by a2 is not equal to b1 by b2, then graph will be a intersecting lines and there will be only one solution and it is consistent. So similarly, the second relationship, if a1 by a2 is equal to b1 by b2 and not equal to c1 by c2, it will form a parallel line and it has no solution and it is inconsistent. The third relation is a1 by a2 is equal to b1 by b2 is equal to c1 by c2 and it will form coincident. So the lines will coincide and it has infinite number of solutions and it is consistent. So by looking into the graph, we can see if we plot two different linear equations on a graph, by looking into the graph itself, we know what is the number of solutions for that and what is the consistency of that pair equations and what is the relationship of that two coefficients. So I hope you are clear on this. So next video we will discuss the various methods used to solve this pair of linear equations. There are three different methods used in algebra that we will discuss in next video. If you are new to the channel, please don't forget to subscribe. Please like, share and comment. Thank you for watching.